Hello, and welcome back to Shiksha DaCosta. Today we're going to review our unit on solving problems involving properties of line segments. In this unit, we learned how to solve problems using analytical geometry, especially if that involves the properties of lines and line segments. And as part of this, hopefully you were able to develop the formula for a midpoint and the length of a line segment, and use those along with the slope of a line segment to solve problems. As well, maybe you were also able to develop the equation for a circle that has its center at the origin and a radius of r. And that's sort of an extension of these line segment ideas. And then using that, were you able to determine the radius of a circle given its equation? Were you able to write the equation given the radius? And finally, hopefully you're able to sketch that circle if the equation is given to you. We started off by looking at the length of a line segment. Now, a segment on a line is just a portion of a line on a Cartesian coordinate plane that is connected by two endpoints, or it connects two endpoints. And those endpoints, we could label them as A or B or whatever letter you prefer. And this is an example of that. So here we have point A and point B. If these are the two endpoints of the line, well then the line segment, then the line segment AB can be described just like that. And this is the notation for it with just a bar over the top. Now between these two, the difference in their y values, which we might also call the rise, and we might also write that as delta y, can be calculated by subtracting those two y values. That's that measurement right there. Similarly, the difference in the x values, the run or delta x, can be calculated just by subtracting the x values, and that's that measurement right there. And if you notice, these two are perpendicular to each other, and therefore they might form the legs of a right triangle. And we know how to find the length of the hypotenuse of a right triangle. It's just a squared plus b squared, and all square rooted. So in other words, delta x squared plus delta y squared equals the length of AB squared. And if we isolate for the variable line segment AB, this is the formula for the length of that line segment. After that, we looked at the midpoint of a line segment. So the midpoint, as we can see in this diagram, is right in between any 2 points, and we can split that larger triangle up into these two smaller similar triangles, where the run of each of the smaller triangles is half the run between these 2 points, and the rise is also similarly half the rise. Its formula for the midpoint is just here. All we have to do is average the x coordinates and average the y coordinates. We also learned in this lesson about right bisector. So a line is perpendicular to another. If their slopes, when we multiply them, we get -1. Or in other words, if their slopes are negative reciprocals of each other. And to find the equation of a right bisector, so it has to meet the line segment at a right angle, and it has to bisect it. In other words, it has to meet it right in the middle, at the midpoint right there. To find the equation of that, well, we have to first find the slope of the line segment, then take its negative reciprocal to find the perpendicular slope, and then to find the y-intercept, we substitute in the coordinates of the midpoint and solve for that y-intercept. Analytical geometry is the branch of math that marries algebra to geometry, and we can use these formulas like the length, midpoint, and slope of a line segment to solve problems involving any diagrams that involve geometry. When you're doing so, if you have a coordinate plane and a graph, it can help you verify your situation visually or your solution visually if the algebraic solution isn't convincing enough. Finally, we looked at equations of circles throughout this unit. The equation of a circle with the center at the origin is x squared plus y squared equals r squared, where r is just the radius of that circle. And if I want to sketch that graph, all I have to do is graph these 4 points, right? Take the radius, 0 and r would be the radius here, 0 and r, r and 0, 0 and r, 0 negative r, and negative r and 0. And these four are definitely exactly the radius away from the origin, and I can just connect them then with a nice smooth curve. Just like that. And by doing so, I've sketched out a graph, even if all I've been given is the equation. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.